So I've already been editing my speech because two great speakers and they've said a lot of things I wanted to say. I've made some edits on the fly. We'll see how this goes. Firstly, I want to say it's my great pleasure to serve as the Chief Executive Officer of the Society of Petroleum Engineers. That is the world's largest oil and gas professional association with over 132,000 members in 140 countries. As well as that role, a role I've held since 2023, I'm also incredibly proud to be a member of the Society of Petroleum Engineers and have been for almost 30 years. You can probably tell from my accent, Randy, that I'm not from Texas. I do live in Houston, but it's okay because I abide to the bumper sticker. I wasn't born there, but I got there as fast as I could. And I would also say I read another quote that really resonated with me. It's that you don't just move into Texas, Texas moves into you. And that's a really great quote. We're going to talk a little bit about history. We're going to start with the past, we'll come to the present, and we'll talk to the future, because I'm a big believer that we learn a lot from history. And I think as we're talking about how can the US and the globe build and scale a true global geothermal industry, why don't we start with a question, which is, where did petroleum engineers and where did the oil and gas industry come from? Well, the answer is the American Association of Mining Engineers, which was founded in 1874. It was started in Pennsylvania by 24 mining engineers, and at that time they were specifically coal mining engineers. So the industry that preceded oil and gas as the primary source of energy actually was the starting point for the Society of Petroleum Engineers. In 1913, AIME formed an oil and gas committee. In 1925, they held their first annual meeting, and I was extremely proud to be present at the 100th annual meeting of the Society of Petroleum Engineers last year, and my friend Katie was one of the speakers. And Chris was actually a speaker as well. In 1957, we finally split into the Society of Petroleum Engineers and the Society of Mining Engineers. But the lesson here is that the existing providers of energy at the turn of the 20th century understood that their skill set and knowledge could be used to help develop a new form of energy, petroleum. As I said, history is a great teacher, and we find ourselves in a very similar spot today. I'm going to talk about three great resources the US has and we can tap into. The vast and abundant oil and gas reserves, which we will need for a very long time. An abundance of geothermal resources that we're only just beginning to understand and tap into. But from my perspective, and perhaps most importantly, it's skilled people and companies that we can leverage in order to deliver those resources. What has been achieved by the oil and gas industry in the last 100 years is quite frankly staggering, and I would put it up against any other industry in the United States today. I don't care if you want to talk about tech, I don't care if you want to talk about space, nothing those industries done can match the contribution to society of the oil and gas energy. I'm extraordinarily proud to be part of that industry. And the only reason we don't get the recognition is because we choose to do all of our work 2.5 miles underground in some of the most remote places on the continent or 200 miles offshore. The technical overlap, as we've talked about, between oil and gas and geothermal is huge, and for that reason I believe oil and gas can solve the remaining technical challenges and help scale geothermal. The industry has actually done something very similar before in the last 20 years by unlocking the unconventional resources that existed to the point now where the US produces 13.5 million barrels of oil equivalent per day and is once again the largest producer of oil and gas in the world. Only the oil and gas industry actually has the track record to develop and scale geothermal and bring it quickly into the energy mix to address challenges like energy security, increased demand for AI and data centers, as well as carbon emission reductions. I'm here to tell you the oil and gas industry is taking geothermal seriously and is ready to engage. And SPE's new tagline reflects our continuing evolution, just as AIME evolved from mining engineers into petroleum engineers. So we are looking at solutions, we're looking at people, and we're looking at bringing energy. Thank you.
So this is Jamie Unleashed because we have a technical difficulty that deprived me of my notes. So we're going to be completely winging it. But to kind of riff off of Simon, background on where the speed and scale is going to come from geothermal, there's a lot of panels today that are going to start diving deep into the technologies, the things that startups are doing, what the opportunities are, what the trends are. But we fully recognize that this is a room full of policymakers and lay people, and we probably need to start from the basics for a second, right? So what are we talking about here? Science. So hang in with me. I'm going to do a very quick overview of the science. What are we talking about? What are these concepts? How can we put them into buckets in a way that will be more understandable? Okay, so that's my role here with this little talk, is to kind of orient you so you can go into the panels today understanding what people are talking about, right? Now, the different aspects of Geothermal House are meant to kind of amplify all of these messages, right? So the startup ecosystem downstairs will represent all of the things I'm about to tell you. There's an entity doing every single one of the things. So I'm hoping you're going to take all of this knowledge and go play with the map and see what the resources are and go talk to the startups, etc. All right, so let's get rolling. Geothermal, massive opportunity. Where does the heat come from? Well, the core of the Earth is 6,000 degrees Celsius. It's the same temperature as the surface of the sun. The surface of the sun is really frickin' far away. Our core is not really that, well, it's pretty damn far, y'all. I mean, it's like 4,000 miles, but it's really close compared to the sun, right? And so all of that heat from the core of the Earth emanates and works its way out to the outer portions of Earth. Now, the crust of Earth is a really good insulator, so it keeps all the heat in. You don't burn your feet when you walk around barefoot outside, right? Because the Earth's crust is keeping all of that heat trapped inside the Earth. But we have got this massive reservoir of heat. So much of it, in fact, and it's so abundant, that the IEA recently, we partnered with the International Energy Agency to estimate how abundant geothermal is globally. And economically, we could produce geothermal at 140 times total global energy demand. So huge, massive opportunity. The question is, how do we leverage it? Now, when most people think about geothermal energy, they think of Iceland. So it's like, oh, that's bathwater, hot springs. I had a nice glass of wine in that. What does that have to do with climate? What does that have to do with energy? I don't get it. Well, that's where geothermal is close to the surface. So there are places in the world, like Iceland, where geothermal, usually volcanic regions, but not always, where geothermal has made its way really close. It's really hot, perfect conditions exist, so there's water underground, there's the right amount of pore space underground. It's really easy to use the resource, tap the resource. So in places like Iceland, they have geothermal power, they have geothermal heat. That's called traditional geothermal or hydrothermal. What's new, and what you're seeing now on the screen, is next gen. What's new in geothermal, and these are all startups, many of them are actually here, you just saw Cindy Taff on the screen. What's new in next generation geothermal is taking what Mother Nature gave us in places like Iceland and figuring out how to engineer it to do it everywhere, anywhere in the world. Right? And that's where you hear Simon riffing on the oil and gas industry. The oil and gas industry is really frickin' good at engineering the subsurface, right? So oil and gas, exploring for, drilling for, and producing subsurface energy. They know how to engineer these systems. And so you'll see, not only in startups, but also in many of the panelists today, oil and gas industry veterans that are leading next generation geothermal. And why this is new is because of the shale boom. So we'll talk about that in a second. But 20 years ago, we didn't have the technologies to engineer the subsurface. We do now as a result of directional drilling, hydraulic fracturing, and other technologies that have been developed by the oil and gas industry. All right, So let's talk about the different types of geothermal. So this is where folks often get lost, right? So, and when you see it, you'll see it in the startup ecosystem downstairs. Everybody's doing something different. So let's try to put some concepts into buckets. Heat. Geothermal is heat. It's hot under the ground. So when we produce heat to the surface, we can use it for heat. So that is called direct use. Heat to heat, direct use. Usually that's shallow. So it'll look systems like district heating systems. So this is that type of system. We drill, but not super deep. We produce a networked system, and we use that networked system to leverage the very consistent temperature in the shallow subsurface to heat and cool buildings. So these are called a lot of things: thermal energy networks, district heating systems, shallow geothermal. It's heating and cooling. Geothermal for heat. And you can use heat for buildings, yes. You can also use heat, and this is a really interesting developing area, you can use heat for industrial processes. So like agriculture and greenhouses, yes, but also chemical manufacturing and these sorts of things, these higher temperature processes. And there are startups here today that are working on that. So that's geothermal for heat. Now, geothermal for cooling. This one is less intuitive, but if you've ever been in a cave underground, it's cold in there, right? It's like 50 degrees, 55 degrees Fahrenheit year round. That's air conditioning that's free. So in a very simplified way, you can think of geothermal cooling from the shallow portion of geothermal cooling, using that free air conditioner underground to cool things that we need to cool. So yes, air conditioning for places in the developing world that don't have enough electricity to electrify cooling. But in this situation, in this graphic that you see, this is a data center. And you're going to hear a lot of this today. AI, data centers, how geothermal can help. One of the emerging areas and kind of low-hanging fruit for geothermal for data centers is data center cooling. So if you see in this graphic, that's the data center over on the, it takes a little bit of a jump of imagination, but that's a data center over there on the your far right, and it's dumping heat. So you've got the red going down into the ground. It's dumping its waste heat into the subsurface, and it's cooling the fluid that then gets circulated back to cool the data center. So yes, you can use geothermal power for data centers too, and we're going to talk about power now. But the really near-term opportunity for data centers, the things that's happening right now, is cooling. All right, so geothermal for power production. So geothermal is heat, right? So that means we produce it to the surface, and then what? We have to convert it to electricity. Now, as a general concept, and startups don't get mad at me, like we're a nonprofit, we're neutral, so we just kind of say it how it is. Power production is more expensive because there's a lot of inefficiency. So when you take heat and you produce electricity with it, you have a 12% conversion inefficiency. You get 12% out what you put in. And that makes it really hard to make electricity in an economically feasible way with geothermal. And so when you talk with startups right now and they talk about reducing drilling costs, speeding up drilling time, they're all really trying to make these numbers work. They're trying to make the business model work for geothermal for electricity because it's awesome for electricity, as you heard from the senators and representatives this morning. So geothermal for power production. This turns into a word salad because you'll hear today EGS and AGS and all of these various acronyms. Really what we're talking about in NextGen is engineering the subsurface, right? So making something exist that didn't exist before, meaning sometimes you don't have enough water underground like in Iceland, so you need to introduce more fluid. You don't have enough pore space like in volcanic rock, so you need to use hydraulic fracturing technologies to create that pore space. So if you look at this concept, this is what, and by the way, not an engineering diagram, not to scale. This is for lay people. This is what's called an engineered geothermal system, or EGS. And essentially, in a very simplified way, you have two wells that you drill to various depths. And if you want to know how deep you need to go for what, go to GeoMap, and we can point it out for you. The geomap display outside, actually, you can pick congressional districts and see, what your heat is underground. But you drill 2 wells and you fracture in between the wells. And in a very simplified explanation, you're circulating fluid through the fractures and producing heat to the surface. And that's a power plant in this graphic. So in this graphic, you're producing electricity. And so when you heard the representatives this morning say, Fervo's project in Utah, this is the type of project they're speaking of, EGS. Next, let's go ahead and talk about super hot rock. SHR. So we have startups in the room, in the startup showcase below, in first floor, like Quays. They're a group of technologies, techniques, and ecosystem members who are trying to go deeper and hotter to try to get EGS to work. The reason they're doing that is because hotter has much more energy density. So if you are able to go super, super hot and deep, then you are able to produce more electricity and kind of go head to head with major baseload power plants like nuclear facilities and natural gas plants, right? So shallower EGS, because it's not as hot, it's a little less efficient, you get a little less output. If you go super deep and super hot, you get way more out of it. So that's what they're after. They're after that prize. And so you'll see, deeper than a shallow EGS. Next gen concept, closed loop systems. So CLS or AGS, advanced geothermal systems. And I'm sorry. So when it comes down to it, this ecosystem is in renaissance. And in renaissance, people just start throwing out shit. And we've got all kinds of terms going. I mean, there's a new one all the time. And everybody wants to name their own thing so they can have their own piece. So we have all these acronyms flying around. Eventually, it'll all shake out, and this will get more simple. But for right now, we got a lot of names. AGS, Advanced Geothermal Systems. Same concept, basic. You're engineering. You're not fracking. So in AGS, you are directionally drilling the entire system. Now, what does that mean? It means that the system is not as capable of absorbing the heat from the rock. That means that the output's a little less, right? And so right now, closed loop systems, or AGS, are by and large producing heat. They're direct use systems. The shallow systems, like the one with the houses, is an example. But this is a deep AGS. And the aim here is to focus these technologies on places in the world where fracking might be banned, or where you have social license issues in using hydraulic fracturing. And I think the goal is, over time, though this needs a little bit of technological development to make it economically feasible, the goal is to be able to do this economically anywhere. But this is just drilled with no fracking. All right, so let's compare side by side. So we were almost through the science piece. This is the whole spectrum of next generation concepts. And you'll see we've got shallow for heat, heating and cooling. And by the way, heating and cooling is 50% of the geothermal opportunity. But it does not get 50% of the attention. Help me change that. Help the startups that are working on it change that. Because it's very sexy to go after power. It catches headlines. Heat is not as sexy, unfortunately. I think it's sexy. But it's not, right? But if you think about it, if we heat and cool, 50% of the world's energy demand is heat. If we knock that out with geothermal, that's 50% of the world's energy demand. It deserves attention, right? So you've got on the far, shallow systems that are for heating and cooling. And as we move to your right, you've got deeper and more technologically complicated concepts. And as you move across the spectrum, you're going to get increase in expense, so it gets more expensive to do the projects, and it also gets less and less technologically enabled. So Representative Weber mentioned the need for research. When you look at super hot rock, That's where research is needed, right? Material science research, some really cool technology transfers from defense and space into geothermal. I mean, it gets really cool, but we need to do some stuff. There needs to be some technological development. And the reason that is because, frankly, when you get that hot, everything melts. So we need better materials. Okay. So there's all the word salad. You will hear all of these things today. Really what this is about is a technological renaissance and a flourish, right? And it's kind of been compared to the shale boom in oil and gas. And I think that's probably correct as we watch over the next 10 and 20 years, the growth trajectory of geothermal and next generation concepts. And the reason that is because we can leverage the speed and scale of the oil and gas industry. So let's talk about that for a second. The oil and gas industry currently drills 70,000 wells a year for oil and gas globally. If we were to drill 70,000 geothermal wells a year globally, by 2050, oh no, can y'all see that? Yeah. By 2050, we will have met 77% of global electricity demand and more than 100% of global heat. So let me say that again, because you have to say things 7 times for people to absorb it. If we drilled at the rate we drill for oil and gas right now, by 2050, the world is powered by geothermal. That is a very big deal, and it's a huge opportunity for the oil and gas industry. But the oil and gas industry is essential in making that happen because of the global footprint, scale, skilled workforce, et cetera, right? So that's why you'll be hearing from folks on panels today in the industry talking about the opportunities for the industry. And just to say, as you work your way through the exhibits today, one thing, if you're wondering about the concepts, in Geothermal House, we have a VR experience downstairs. So it walks you through all of the technologies that I did today, but in 3D, and it takes you underground to see what they look like. So make sure you do that before you leave, because it gets you kind of this 3D experience of what I've just described. Same thing goes for if you're wondering about where in the world geothermal is the shallowest. That's GeoMap, and go and try to experience that as well. And of course, if you have any questions about any of this, there's 10 staff members around. So please hit us up. Massive opportunity. Thank you all very much. Enjoy Geothermal House and the panels, and we'll see you around. Thank you.